All right, everyone, we are ready for our next talk with Micah Green, a cybersecurity engineer, teaching us about intro to cybersecurity and how to get started.
Thank you. So I'm going to go pretty quick through this. Feel free to throw up some hands. But first off, I have to turn on triple speed, which is RGB. Very important. So we're going to go over an introduction to cybersecurity engineering, and a little bit of the why is how we're going to start out with. So there's a popular or a video out there that kind of went a little bit viral about how we as humans deal with hard things every day. And when we're kids, everything might seem hard. But when we grow up, it's not that hard, it gets easier, because it never does. It stays hard, but we do hard better. And so from that perspective, let's walk a little bit in the shoes of a cybersecurity engineer, why we exist, and what value we provide to the enterprise. So the original cybersecurity that I kind of started playing with when I first started joining up with different organizations, military and otherwise, was called the golden disk. So we would have a disk that was literally golden color, and it would have our default operating system on it with whatever kind of general security things that we wanted to implement on that golden disk. You'd take that out to a CD or DVD player. That's an old thing. It used to spin like a pizza, and then install everything on your computer. So once that was installed, we started working through how we're going to deal with change management, how are you going to deal with viruses popping up and patching and all that kind of stuff. That gold disk turned into this. For the military, for the DoD, there was an executive order that was signed that says all DoD and government entities had to follow RMF and some other stuff that I'm not going to get super deep into here. But this is just the governing documentation that kind of gives you a good idea of how difficult it is to secure a network, especially when you're talking about government networks. But as we see more and more cybersecurity exploits and ransomware releases, this is starting to become the norm for most of your organizations, financial being one of the major places that does a lot of investment in cybersecurity. So how are we going to take the regular things that we do as a company and categorize off into separate segments what the risks are that we have to deal with? And I'm going to very lightly touch on risk here, which is if you implement cybersecurity to the full extent of that last policy document, nobody's going to be able to connect to the internet. Nobody's going to be able to gain and maintain customers. And so how do you balance that? So that's where the different quadrants of risk start to come in. Like your financial risk is a big one. Like, do we care as much about the cybersecurity on this system where we have to take it offline, or is that how we get our business? If you have a forward-facing website, you have to maintain that in an internet-connected manner to be able to gain and maintain your customers. So that's one of those different risks that we talk about. And then you get into other stuff like strategic risk. How are you going to strategically grow your company? Make sure that you get a lot of presentation while still mitigating people attacking you when they know who you are. That's one of the benefits of not being a well-known company, but also you're not going to be making as much money a lot of times. So when you grow, all of the other risks have to be balanced. So I'm going to talk mostly about the information transfer area of the risk equation, and I love going to SANS posters. So SANS posters are free. You can go download them from the internet. If you're a SANS member, they'll mail you out paper copies often. And I like to talk about going from that business knowledge as it increases as you move up the pyramid. Down at the bottom is where you have your people that type on keyboards every day. That's where you have the people that are administering the systems talking to your security engineers and your security architects to understand how you're going to secure these business critical systems as you expose them to the internet. And so the security manager, the security leadership, and the executive departments, they have reports on their executive leadership meetings, their board reports, where the board of directors says, hey, we want to make sure that we are able to maintain our customers by advertising that we have good security at our company. The board of directors is going to look at their technical leadership and say, how the heck are we going to do that? Because they might not have touched a keyboard in a little bit. They're focused on strategy. They're focused on how do we make more money. Security oftentimes is a hindrance to that. And so they need that information flow upwards, and then they're going to start pushing that information back down to the technical level simply by writing policies, strategies, and stuff like that. So how do you take that high-level strategy and push it back down to an engineer when they're just focused on writing Java, Python, whatever kind of code it is, and trying to get it out to deliver value from a user perspective? That's where you have a concept in cybersecurity called the 3 lines of defense, where you have the bottom line of defense focusing on their admin activities. So this is not a team that is every single time they deploy something, they're going to understand every single control that could possibly exist on that huge sheet of controls. No, they're going to reach out to consultants, whether they're in the security area, whether they're in the governance area, and they're going to say, hey, what are the key things that I need to know to push my product to production? Is there anything that you can do to make my product get there quicker? And there is, and we're going to talk about that in a little bit here. Those consultants are talking with framework people. They're going to establish what your standards are for your framework for your company. And then both the framework and the consultants are going to talk up to auditors to say, hey, are we hitting our Sarbanes-Oxley requirements, for instance? Are we hitting our NIST requirements to maintain a connection to all of these other external entities? So I just want to preface some of the following conversation with this graphic to talk about the different types of frameworks, because that's confusing oftentimes. Like when you say 853, people interpret that as every type of framework you've ever heard of, which it's not. So 853 is control framework. That is like the little, implement secure password stuff. That's what that is. Your next level of frameworks is when you get up into the more executive leadership, how are we planning around a program? What are the categories of control that we need to implement? Like, are we implementing data recovery? Are we implementing logging? Those kind of concepts are the program framework, which you might select some of those control frameworks. And then when you get into a real mature program, that's when you're going to start considering things like risk. Is it more risky to leave that web server out there with the thing that makes it vulnerable while still maintaining connection to your customer? Or do you need to shut it off because it's not worth the risk the benefit that you're getting from it? So that's a little bit higher up. And I'm going to skip over some of these next ones, or I'm going to go very quick. So how do we conduct risk assessments to understand where we need to put our security engineering? Well, we assess the assets, the threats, and the vulnerabilities, in short. We then take that assessment and we establish a management framework. We identify the risks, we analyze those risks, we evaluate the risks, and then we select the risk treatment options. And this is the key. This is what we can do with risk. We can avoid them. That's, hey, we're not even going to use that system. We can modify them. We're going to put in a compensating control, like a firewall in front of that web application. We can share the risk, so we can give it off to a SaaS vendor. That's a common thing that everybody is doing. We call that SaaS denial. We're going to deny our risk by putting it on a SaaS vendor. We can share that risk by putting it over there, or we can retain the risk, saying, hey, the risk that we're retaining is not significant enough to stop this line of business or this access that we're granting and the benefit we get from that. So that was very quick, and I'm going to move into how do we do some of the security engineering. So this is a key area that is easy to understand. I really like the CIS controls, the critical security controls. So it talks about the key areas that you need to focus on to make sure that you're doing cybersecurity engineering correctly. The number one, and oftentimes the hardest, is inventory your hardware and assets. Like inventory them. You cannot protect what you don't know exists. So inventory those. Number two is right on that same vein, inventory your software. If you don't know what's installed on those endpoints, once again, you cannot secure it. So I'm going to skip over a lot of the rest of them. You might have seen these before. Definitely very good to start out with if you haven't gotten into cybersecurity, to look at these. And then I'm going to talk about what cybersecurity engineers, how they contribute to that equation. So we came up with this concept or this verbiage where I work called the golden path. So how does a software engineer that just got out of college go in and start writing JavaScript and then push that somewhere? They're not even familiar with what a web server is yet. They just know they write this code, it's going to generate some HTML, it's going to push it on a web page, lots of money is going to be made. Well, once you start to get a little bit more mature in your engineering space, you start to realize that, well, shoot, not only do I have to secure every time somebody puts something in an input box to make sure that it's not breaking my database or pulling data or manipulating data, that's the first thing they're going to see. I have to understand what the web server that it's running on, how is that secured? What is the firewall that's in front of that guy? What is the access controls? And that's just too much for an individual to understand and work with. And so that's where we come in as cybersecurity engineers, and we focus on each one of these paving stones by looking at the edge stones, as I call them, which are our security by design, our configuration, our policy, what controls, what SCAP, what STIG, what OSEC type things that we need to implement. That's our guidelines to start building out that path for the engineer so that we can get to that endpoint, which is Oz, basically, the Emerald City, which is represented here by developing or delivering customer value or shareholder value for a publicly traded company. And that bottom one there being one of the most important things to be able to stay in business, which is Securities and Exchange Commission. You have to do your change management stuff. You have to show that you are a responsible company doing business, so you don't have a situation like FTX or Enron or whatever, where they just dump all your money into whatever pockets is closest. So that's kind of the key point here. And I'm not going to get into a lot of technical details, but I am going to share some of my resources to get a little bit smarter on cybersecurity engineering. And I'm also going to touch very briefly on this deployment pipelines automation. And I don't know if I have the slide here for that. Let me check here quick. Maybe. So for a CI/CD pipeline, the value that you're presenting to the engineer is that when they click commit to GitHub or they approve a pull request, what has to happen after that pull request? Oftentimes the engineer doesn't know. So one of the things that a lot of people don't know is you have to have a change record that documents exactly why that change was implemented, what changed, and that has to be logged so it can be audited up to 5 quarters per Sarbanes-Oxley, which is the anti-Enron policy, because we want to know that that change you just put in isn't siphoning money off and putting it somewhere, isn't presenting a new vulnerability that the leadership didn't get to pre-approve or say, we're not putting that on our network. And so when you commit something through a CI/CD pipeline, which is continuous integration, continuous delivery, that's where I click a button on GitHub and I say, I'm going to commit this code. The things that kick off in the background is something like a tool like Fortify, maybe something like White Source or Dependabot, which is looking at the code that you're using and the publicly available libraries that you're using and saying, hey, does this have already known vulnerability registered against it? If you're looking at Fortify, something like Fortify that does your actual code evaluation, so it'll look at your SQL select statements and say, hey, are you using a common escape function to make sure somebody can't do an SQL injection? Because if you deploy that code, you push it directly to production, that's kind of like doing 0 days as a service. And you don't want to do that. So you want to identify all those vulnerabilities before you push them to production. And that's what this deployment pipeline can do. So as soon as you click go, it's going to kick off a build where it does the scanning of your code, it looks at all your SQL select statements and many other things and says, hey, you have these higher critical vulnerabilities. We're not even going to let you deploy that or commit it to your branch until you go and fix those first. So you're addressing all of those 0 days before they ever get to production. And the reason why that exists is oftentimes because some cybersecurity engineer built that mechanism, that automation, to evaluate your code before it ever went to production. And you might not even know it existed, except for that big red thing on your dashboard that says you're not going to get deploy here, not today. and you go back and you yell at the cybersecurity people, and you're like, why are you stopping everything I'm doing? And I'm like, no, I'm enabling it, because you'd have to go through a lot of hoops to get to the Emerald City otherwise. Otherwise, you just can't do business as a federally traded company. So that's my quick spiel. I want to touch on some of the ways that we evaluate some of those cybersecurity engineering things that we do. So as we find additional vulnerabilities, whether those are CVEs or vulnerabilities found through penetration testing of our applications, we might rate those using something like the CVE calculator. And we say, this is a known vulnerability. Anybody could run an automated script against this SQL input field, and they could get root on our boxes. And we do that calculation to say, hey, what is the criticality? That might be 8.8 in this random example. This is a CVE I just pulled up on their site. What we do as cybersecurity engineers is we look at our infrastructure, we look at our implemented controls, and we say, can we put in temporal or environmental controls to present that or prevent that from being an 8.8 and take it down to something that might be acceptable to a business owner that accepts risk? Maybe a 6.5 is a reasonable amount of risk to accept. And so the cybersecurity engineering implements those different controls through pipelines, through security as code, through implementing stuff in lambdas and controlling the environment using security posture management tooling, which I'm going to touch on here briefly, to be able to make sure that you as an enterprise are not vulnerable to the most common attacks that are just everyday attacks. They might have been out there since 2013. You you download that open source software that everybody's been using, like something like Log4j, and you just put it on your network. So we focus in that area, we mitigate the risk, we do some continuous monitoring and assessment, and then we use tools. This is just a random, this is like literally the slides off of their website. I really like this tool. They just got their one of their certifications. It's open source, it's based on Elastic, and it basically gives you the visibility into all of those things that you're trying to design the cybersecurity controls around, so that you know, hey, I have a vulnerability here, or I have an exposure here. And the one I really like to show here is OpenSCAP. So you see the past and the failed things there. You see the compliance alignment, which is what all companies and everybody that's trying to sell you a piece of software is probably going to highlight. Hey, we align to NIST, absolutely. And they're going to try to sell you on that. Those are things you have to consider when you're designing software, when you're securing an environment, because when an audit comes back, that's the type of stuff you're going to ask. So I'm going to skip through a lot of these and jump to questions. Any questions? Go ahead. CD-ROM drives something. I didn't hear the rest of that. Yes, they are called cup holders. Yep, very handy for that. So one other thing I want to touch on is how do you get started? So I do STEM stuff for high schools and stuff like that, teaching about cybersecurity, teaching about how do you learn about computers in general. There's tons and tons of resources. There's tons of really fun resources for kids and a little bit for adults. This is just a random list of hacker games from Steam. I really like some of these old ones. And not only do they give you a gamified version of hacking, they'll actually walk you through step by step. Okay, this is a situation where you're going to use traceroute. You're going to use ping. You're going to use anything like that. And it steps you through to give you the basics of how do I learn about cybersecurity. And then once you get into cybersecurity a little bit and you understand some of that source code protection, you understand some of those controls implementation, it's really fun to come back here and start playing and being like, wow, I didn't think about that attack vector. I didn't think about this particular really dumb way to get into a machine, which it kind of gives you that education. So, is it not? Oh, hold on. I got to reshare my screen. I'll try to reshare my screen, but it's basically just a screenshot of games from Steam on hacking. And if you want to know about them, I have a whole list. So you can just Google hack or put hack into Steam search, and it'll give you a lot of good stuff. So that's what I had. I'm not going to try to drag it on too long. Any other questions? All right, awesome. Thank you very much. Is this still live? If anybody wants to see those games, you can come up and check them out. I'll demo. Very fun.